Trigger is to establish multiple analysis time segments in a trigger timetable based on a trigger channel. With such trigger timetable, signal analysis can be performed at multiple trigger time segments either in play mode or averaged over multiple trigger time. It is similar to PST except trigger time is generated automatically and can be used as a subset of PST. Trigger is useful for analyzing data such as this hammer test for structure mode identification. The frequency response function or FRF between two structure locations can be computed from a hammer excitation and a vibration response measurement. Multiple hammering at the same location are usually conducted so that averaging can be performed to minimize statistical variance. In this case, Trigger provides a convenient feature for its signal processing. Right mouse click on Trigger to bring up its menu. This trigger menu is consisted of three parts: trigger time generation, trigger timetable, and trigger processing mode. For trigger time generation, first select trigger channel and threshold level. A trigger event is defined as an upcrossing at threshold level of trigger channel. If check apply start time offset, a positive offset means the start time of the trigger time segment will be equal to the upcrossing time minus the offset, i.e. before the upcrossing time. Check round off start time to round off to so many decimal places. The end time trigger time segment is equal to the start time plus either one block with block size defined in processing parameter, or so many seconds. This complete the setup for trigger time generation. Now click Generate Update Trigger Timetable button. And all the trigger time found will be displayed in the trigger timetable. Each trigger time segment can be turned on or turned off by clicking on the cell under the active column. The off trigger time segments will be ignored during analysis. The next two columns show the start time and end time of each trigger time segment. If PST is also used, then in the PST column, it will automatically link the trigger time segment to the corresponding PST hashtag as its subset. Such combined usage of PST and trigger time provides an effective way to perform signal analysis for roving hammer test. The last column is peak amplitude, which is the peak value of trigger channel immediately following the upcrossing event. This peak amplitude information can be used to normalize the signal from different hammer events with different intensity. The two buttons below the table are to turn on or turn off all trigger time segments in the table. By clicking on the Mark on Ref Win button, all trigger time segments will be marked in the reference window as the blue highlight. With trigger timetable created, we are now ready to perform signal analysis and generate the frequency response function from these multiple hammer events. There are two trigger processing mode available: Start mode and Play mode. Start mode will average all trigger time segments and generate one final output plot, while Play mode will play through all trigger time segments and generate and update the plot at each trigger time segment. Let's select Play mode first. Now select the analysis channel. Excel in channel 1. Then select the reference channel. Hammer in channel 2. In M1 menu, select cross-spectral analysis. In M2 menu, turn on PSD, FRF amplitude, and FRF phase. In left menu, turn on header, matching, trigger, and also overlay so that during trigger play, the result from each trigger time are also shown in an overlay plot. Now start. As shown in this left plot, in trigger play mode, it will play through the 6 different trigger time and generate 6 different FRF, one from each hammer event. With the overlay turned on, these 6 different FRF will also be displayed. In this write plot in overlay format. Let's turn on this legend to show their line ID. From this, we can check if these different hammer events produce consistent results. Next, let's switch the trigger processing mode from play mode to start mode. And repeat the same analysis. As it play through these trigger time, it will average the results from these 6 trigger time segments and generate one final output plot as shown here. It should be pointed out that the PSD in the first and second subplots are equal to a direct averaging of the 6 individual PSD generated in play mode as shown here. However, since FRF are based on complex averaging, the FRF amplitude and phase in the third and fourth subplots are not equal to a direct averaging of the 5 individual FRF amplitude and phase in play mode.